Hello everyone. What happens when light bends? Not at a mirror or lens, but as it passes through a tiny opening. This fascinating phenomena is called diffraction. Now join us exploring the science, the patterns and wonders of diffraction. If we consider a plane wave of light passing from left to right through a slit, wait, what will the waves look like if it passes through a slit? Will it look like this or this? If you guessed it right, the light waves will look bent. But why? When waves encounter obstacle, they bend around the edges of the obstacles. To understand this, we need an exposure about Huygens wavelengths. Every point on a given plane wavefront acts as a fresh source for another, that is, secondary wavelets, which propagates in all directions with same speed, which looks like spherical waves. Since every point acts as a fresh source, we will take 3 points for easy visualization. The spherical waves get interfered and the resultant wave looks like a straight line. When the considered plane wave passes through the slit, we can see that there is no wave exhibited above the ends of the slit, as there is no emitter or source at the end. This is the reason we get bent waves pattern. As the second plane wavefront enters the slit, the first wave will look bent and propagate towards the right and gets bigger due to the fresh source in it. Does this mean that there is only forward enveloping and the backward propagation doesn't exist? This inconsistency of Huygens is fixed by Fresnel. He explained the amplitude of secondary waves moving backward doesn't need to be same as the secondary waves propagating forward. The source may emit higher amplitude waves forward and even zero amplitude waves backward. To be precise, he said that the strength of the source need not to be same in every direction. He named this as obliquity factor. Fresnel also worked on the phases. According to his explanation of the secondary waves, the Huygens-Fresnel principle was formulated. How does the so far discussed pattern will look if the light wave passes through a single slit? When the light waves bend around the edges of an obstacle, it leads to a unique pattern. If we illuminate a light source through a slit, as we already discussed, it doesn't just continue in a straight line. Instead, it spreads out and overlaps to form a pattern of bright and dark spots on the screen. These spots are what we call as diffraction pattern. To have a clear view on diffraction, we must know the difference between interference and diffraction. So what's the main difference between them? In interference, we see series of evenly spaced bright and dark bands created by two or more waves combined. But with diffraction, the pattern has a central bright area with dimmer fringes around it, caused by the bending of single wave. Interference is all about waves meeting and combining, while diffraction is all about waves bending and spreading out. These diffraction patterns are not just cool visual effects. They actually have a lot of application in science and technology. Diffraction patterns help scientists to understand the limits of a telescope resolution. Diffraction technique is used in X-ray crystallography to map out the atomic structure of materials like protein and DNA. Medical imaging techniques like ultrasound diffraction help in mapping tissues and structure inside the body. Diffraction helps us explore the world from the tiny atoms in a crystal to the farthest stars in the sky. Thanks for watching.